Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I'll be continuing on the second part of the slides, which is related to introduction to software engineering. We have covered the first part during the class, and the remaining of the content, I'll prepare it in terms of a video so that you can view it before coming to the class. Alright, I think we have covered on what is software engineering is, right? The word software and also engineering. When it comes to engineering, it means that we have to follow a set of systematic processes in order to execute the task given to us. In our case, developing software. And then in the following slides and video, we'll be covering on um, different types. So I think we covered this previously, different types of software available, okay, and common techniques whenever you develop a software, and the following part is related to ethics and professional issues that we need to consider if we are working in the software engineering. Okay, before this, I've been covering on software engineering, ethics, and so on, right? Now, in this slide, let's look at system engineering. Okay, system engineering is actually a broader concept. Okay, so software engineering is part of system engineering, right? So when we are talking about system engineering, we are actually looking at the big picture from A to Z, from specifying, then you design. After you design, you implement it, and then you check it, you validate it, and then you deploy. Deploy meaning that you actually install it at the customer side, and then you use it, and then you maintain any social technical system. Right? So the concern with the services provided by the system. Okay, we are also concerned with the constraint on the construction and the operation and the ways that it is being used. Get a big picture of um, to get a big picture. Let's look at system engineer processes. So traditionally, it's actually following waterfall, meaning they do one process after another. All right. Uh, but as time goes along, some of the processes can be made parallel. Okay. And of course, because this is the entire process from A to Z, so it involves different engineers from different disciplines, right? So these are the processes, like requirement definition, designing, system design, and then you do sub-system development. If the system is having many tasks, many components, it is being developed part by part, okay? And then you integrate it, and then you install it, and then as it is being used, you evolve it, and then maybe after a while you need to terminate it. So I mentioned just now, so system engineers is a broader concept. Okay, the one that we are looking at in this course is only one part, which is related to software engineers. Along the way, if it's a system which involves machinery, so it also involved with the electrical, civil engineers. We need to we need also people from the architecture side if it depends if the system is dealing with maybe system engineer in building a smart city. Okay, so we need to have a bigger picture of everything. Okay. Okay, in this introduction slide, uh, they propose you they highlight one of the system that is being used in the current days, which is related to system procurement. This is only an example of many systems available out there. System procurement is like am involved with one research related to software procurement, where we studied the software procurement of Malaysian government. Nowadays, if the government is requiring any services, or they want to buy products from the other maybe other government, other departments, or smaller companies, it has to be through this software system procurement. Okay. So of course the Malaysian software e-procurement is actually in their second version already. Okay, they have updated it after using it for quite some time. Some of the initially before they start, they have defined the system specification. They have the architectural design. Architectural design is more like an overview of the entire system, because this system is large, so it's not only used by the government but also the small companies. So they need to get a big picture of the entire process. Okay, you need a specification to let a contract for a development. For example, okay, let's say one department in the government, for example, Ministry of Higher Education. Okay, they want to have a lab. They want to build a computer lab, for example, in um, one of the universities. So they will try to identify what are their requirements. They will list down all the requirements, and then they will uh, uh, write it down in terms of in a form of tender, and it will be shared to all companies out there that is interested to provide that service. Okay, so this company will actually bid for will will submit their application to uh, we call it as try to bid for the project, and everything is being submitted online nowadays. Okay, so they have to register their company so that the Ministry of Education can see in terms of their financial background, are they very strong, do they have all the facilities, all the technical people. Okay, can they produce based on their previous history of producing similar services, are they in a good term. Okay, so it is actually this system procurement is actually a large system that they there are actually many processes and many modules. Okay, right. So okay, so this is in this slide, this is sharing um, some of the processes in the e-procurement. Okay, so right. So first, they survey the market for existing system. Let's say just now I said to you, let's say the Ministry of Higher Education, they want to establish a computer lab, so they need to be checking around. So what are the existing way that the other companies or other university in different countries are setting up the lab. Okay, so they need to know what is the current spec of the computer, what should be software should be in, what kind of networking configuration that should be there, the kind of monitor, all right, the kind of printer. Maybe they need in the lab, they need to make the lab very mobile so that people can work in a group, or maybe even the tables can be shifted at the side and so on, not like the common lab that the tables are static, they cannot be moved. All right, so based on their survey, right, so they can they have to check whether can they simply buy things available out there. Maybe there is a company out there that is having that kind of functionality, or maybe they need to make it customized. All right, let's see if they find that they could not find companies that is able to meet their requirement. They will write a they need to make it a customized system, so they will issue request to tender. So that's the process in the procurement. Okay, they produce a tender first. They will advertise to all the companies out there who might be interested to get this project, and then based on what has been submitted by the companies, they will try to select the tender. They select the best company that meet their requirement based on the report that they have given. Okay, and based on the track, the history, the financial support from that company, so they will investigate whether which company is the best one, and then after that they will negotiate the contract. Okay, maybe um, they will negotiate in terms of the price. Maybe the price is can be lowered or make it higher, and then they let contract for development. So once they agree, so they will start doing the development. So if the product can be accomplished by surveying from the existing company, or maybe they can buy, maybe out there is several companies is ready with the lab community lab kind of package. Okay, they can change the requirement a bit. Okay, and then choose the system, and choose the system, what kind of system that available, and then the issue request for bids. So they want the issue request for bids is basically they have choose a system, and they will make issue a bid, so that whatever company that is out there that is able to offer them the selected system, that company will submit their bids, and then they for example, in our case, Ministry of Higher Education will decide uh, the supplier, the suitable supplier that they want. Okay, right. So these are some of the examples that deal with this procurement system, where the system customer underneath it. Sometimes when they get a project, it is actually the, for example, in our case, Ministry is Higher Education is having contract with the main contractor, but underneath the contractor, they actually, because they want it to make it faster, so, or maybe they don't have this expertise, so they have other companies to work with them. Okay, so that's the kind of condition in the case of e-procurement. So in the actual implementation of software engineering projects also, so these are some of the things that we need to consider. Okay, sometimes uh, when the main contractor is depending on other companies, so maybe there will be some delay. So maybe along the way there are some communication problem. So those kind of things we need to be aware of. Okay, and also um, when we are dealing with software engineering, we need to also think about the existing system out there, which is called legacy system. These are system which is old, and sometimes it's using absolute sorry obsolete technology. Okay, so slightly older kind of technology. Okay, so we cannot just leave it there, because sometimes it is still running and still supporting the company, right? Among the obsolete kind of technology or legacy system is the aircraft maintenance system. It has been there for quite some time and it's still running. And also accounting system, banking system, some of the main processing is actually using legacy system. Okay, legacy system constrain new business processes, yeah, because it has been there. So if you want to change here and there, maybe it is cannot be done. And if you still want to do it, maybe it's using lots of budget. Okay, okay. This is just to give you some idea how legacy system is. Okay, so this is this application software. So of course it's using data, and then it depend on the hardware of the system. Most of this legacy system runs on mainframe. I'm not sure whether you have seen mainframe before. Basically, it's a big computer in a very big room. Okay, it has very fast processing power. It's not like laptop with that runs with limited resources. Okay, and then of course this application software, if we take into account an example just now, accounting system. So it also communicate with other software, maybe software for printing, okay, software, it needs information from other parts of the system, it needs the support of the software, right? And of course, this application software itself, it follows certain business rules that have been designed for them. Okay, if you want to change, maybe the system can be changed maybe in terms of the business rules. Okay, and also it depends on also the business processes that have been set earlier. Okay, so basically this is how the legacy system is. Okay, so the core system is here. So it get inputs from the business rules, from the business processes. In order to process, it will extract data from a specified place, and then along the way it needs supports from other software, maybe for printing. Okay, maybe the data that is being produced from this legacy system will be put to another software that maybe will change it, will show it in the mobile apps or on the web. All right, and it depends on the software that is running. Okay, it's a quite lengthy kind of discussion. Um, um, so basically, in the software engineering, it is an engineering discipline, even though it's not as thorough as detailed as the one in the electrical engineering, mechanical engineering. Still, it is following certain set of processes. I've mentioned just now, when we follow a set of processes, partly we are actually trying to be ethical in conducting the job as a software engineer. Okay, essential software product attributes are when you are describing a software, we are talking it in terms of whether the system is maintainable, uh, whether it is dependable to other attributes, whether is it secure, efficiency, and acceptability. So these are kind of description that you can use whenever you describe a system. All right. High level activities. Okay, I've mentioned just now, when you are developing system, there are sets of common activities that you normally perform. So as a whole, in general, you can say that uh, the first activity is identifying the specification, and then you develop it, and then you do validation, and then evaluation, and so on. Okay, and then I've mentioned later on that there is a concept called the fundamental notion of software engineering are universal. All right. Oh, and then we are looking at different types of application, right? Standalone, embedded, um, what else? Modeling and simulation. Yeah. And then we are also looking at, we look at there are many types of system, and each one requires different tools and different techniques in order to develop it. And then we look at fundamental ideas of software engineering are also applicable to all types of software system. We look at that even though we are using different types of developing different type of system, okay, requirement is still important. Okay, the issue of dependable and security is actually common across different software. And then we look at the ethics for software engineers. Okay, not only concerned, we are when we are dealing with software engineering, is not only concerned on the technical aspect, but also on the soft side, whether they are being ethical, um, uh, are they preserving the integrity when they are working. Okay, professional societies publish codes of conduct and set the standard. Okay, so so they are doing that so that to ensure that everybody is working on the right track, following the kind of quality that software engineering